morning and welcome back. So today we're going to review how to graph vertex form. So on the board I have the basic equation for vertex form. F of x equals a times x minus h squared plus k. You're probably thinking, what do all those letters mean? Well, the whole reason it's called the vertex form is because the vertex is actually hidden within inside the equation. So in this case, your h value and your k value are your actual vertex. So you'll see a lot of times on your notes, h and k equals the vertex, all right? They're just letters that mathematicians use to indicate the vertex. The h stands for your horizontal movement when we get the transformations, and k stands for like vertical movements when we also get the transformations, which we'll do in our next class. All right, so here, if we wanted to graph this information, we're going to pull out the actual vertex. So if I pull out the vertex, the number I plugged in to get a positive 4, if it's originally a minus 4, I must have plugged in a negative 4. Right? This is always backwards from our x value of our vertex. Because I plug a negative 4 into the original equation, a negative is what gave me the positive form. The y value, or my k, is still just true to form. It's negative 6. All right? So that's going to be the vertex of my graph. So we're going to go ahead and plot that on the graph. So I'm going to go to negative 4, negative 6, and plot my vertex. All right. Now, what we have when we have a quadratic, we have something called the axis of symmetry. The axis of symmetry is a vertical line which goes straight down through your vertex. It divides the parabola, the shape of the graph, evenly in half. So I'm going to go ahead and just, for purposes of graphing this, kind of draw in my axis of symmetry because it's going to help with graphing later. All right. Now, the shape we're going to use for a quadratic equation is a parabola. It's going to be a u going up or an upside u going down. So what we want to do here is we have to come up with points on different sides of our axis of symmetry to find out where the parabola is going to go. So we're going to make a little mini data table for x and y. And I'm going to pick 2 points on either side of the graph, either the left side or the right side. It doesn't really matter when I'm starting out because I'm going to use the axis of symmetry to plot the points on the other side of the graph. All right, so looking at this graph, you want to pick 2 points on your x-axis which are pretty close to your axis of symmetry. So I'm going to pick an input of negative 3 because it's only 1 unit over from where my axis of symmetry is, which is x equals negative 4. So I'm going to use negative 3, and let's go ahead and use negative 2. All right, so what I want to do is I want to plug these 2 points into the original equation to find out what my output is or my y value. And don't forget, f of x is the same thing as y. This is more standard algebra. This is when we're dealing with functions, so they could use the letter f or g or h and whatnot. All right. So we don't need the vertex anymore. We already have that. So let's plug in negative 3 in for x. So if I do that, it's going to be 2. It's going to rewrite the equation, negative 3 plus 4 squared minus 6. So my input is negative 3. All I'm going to do is solve for this, and that will give me my f of x or my y. So what I need to do is I need to follow the order of operations, so I'm going to solve what's inside the parentheses first. So this gives me 2. Negative 3 plus 4 is simply 1 squared minus 6. Then if I square 1, I get 1. So now it's going to be 2 times 1 minus 6. I still have to follow the order of operations. I did parentheses, I did exponent, now I'm going to multiply or divide from left to right. This gives me 2 minus 6, which would be negative 4. Oops. There we go. So if my input is negative 3, my output is negative 4. All right, let's do one more because I need another point. So let's get rid of this. Get rid of my input. Now I'm going to plug in negative 2. All right, now I'm just going to solve for the output. So it's going to be 2. If I do what's inside the parentheses first, I'm going to get a positive 2 because negative 2 plus 4 is a positive 2. Squared minus 6. I'm going to square this by doing the exponent part next. That's 2 times 4 minus 6. That will give me 8 minus 6, which will give me 2. All right, now that we have these 2 points here, we can graph them on one side of the equation. So let's go ahead and do that. This first point is -3, -4. So I go back 3 and down the 4, plot that point. Now this other point is going to be somewhere up here because we want to see how the parabola actually extends up. So it's going to be -2, 2. So -2 and 2 would be right there. So we have those points. Now, I can go ahead and graph that side of the parabola. It's going to go through those different points, and I have my right side of my parabola. But remember, how we're going to graph the left side. We have the parabola as a U. Well, remember the axis of symmetry? That's a line, remember, that goes right down the middle and divides it perfectly in half and makes it symmetrical. So, it makes graphing the other side simple. Do you see this first point we actually graphed right here? Well, there's going to be another point the same distance from the axis of symmetry on the other side, on the left side. So if it's 1 unit over from the axis of symmetry, I'm going to go 1 unit to the left of the axis of symmetry and put another dot there. That was easy. And then if this is 2 units over, I'm going to go 2 units to the left on the same line and put another point here. Now, I can graph the other side. There you go. Ta-da, you have your parabola. If you notice that there's a number out in front, it's going to be a vertical stretch. It's going to make it taller and more narrow. This is a little bit more narrow than a typical parabola. If it's a fraction, it's going to make it a little bit wider. It's called a vertical compression because it's kind of compressing with the x-axis. All right, let's do a couple more. Let's get rid of this. All right, let's do f of x equals, try to do some examples from my class, x minus 4 squared. All right, so let's pull out our vertex. Remember, this is the h value. That's the x value of your vertex. So I know it's going to be, I'll write it up here. That way I have plenty of room to write in my math later. So it's a positive 4. Because when I plug a 4 in there, it still stays -4. Remember, your x value is always kind of opposite whatever this is. If that says -4, your x values will be +4. If this is plus, that's going to be minus. Just remember to switch it. All right, now I don't really have a k. There's no number out here. So that's like saying plus or minus 0. So my y value is going to be 0. All right, now I have my vertex. So I'm going to mark this at 4, 0, which is right there. Now, once again, I'm going to pick numbers that are really close to this because I got to find out how my parabola goes. I always use x and y. Let's go to the left side this time. So let's do 3. Let's do 3. And let's do 2, I guess. You got to be careful when you pick your numbers. They literally can be any numbers on either side. But you want to stay close to your vertex because sometimes if you pick too big of numbers, you're going to end up way off your graph, and it's going to be a complete mess. Just try to stay as close to your vertex or your axis of symmetry as possible. All right, so we're going to use, oops, I didn't mean to put the 2 there. My bad. There we go. So my first input is going to be a 3. So I get 3 minus 4 squared. Now I have less math to do because there's no plus or minus k at the end. This is going to be equals -1. It's -3 minus 4 is -1. -1 squared is 1. There. Got my first point. Now let's plug in the 2. All right, so if I plug in the 2, 2 minus 4 is -2. -2 squared is going to be 4. Got my 2 points. 3 and 1. So I'm going to go 3 and 1, which is right here. I'm going to go 2 and 4, which is up here. Now, we have the one side of our parabola. And now we need the other side. So remember, we have our axis of symmetry. Which goes right down through the middle of the vertex and is a perfectly vertical line. So now I can graph my matching points on the other side. Well, if that's 1 unit away, that's going to be 1 unit away from the axis of symmetry. If that's 2 units away, it's going to be 2 units away on the other side. There you go. Easy peasy lemon squeezy. We got it nice and good. All right, that's another one. Let's do one more. All right, one more. We'll throw some different numbers on here. Let's do one with the fractions. So we can kind of like see the difference. All right, fraction. Let's do x minus 4, and we'll do squared plus 2. All right, there we go. So now we have a fraction out in front. All right, no big deal. Even though we have a fraction out in front, my vertex here is still going to be a positive 4 and a positive 2 now. All right, positive 4 and positive 2. That goes over 4. Oops, let's get rid of that line. And up 2. All right, there's my vertex. Tell you what, let's make this a negative. All right, because a negative is also going to flip your parabola upside down. Doesn't change too much, but let's make it a negative for the sake of a better example. All right, I have my point, and I know my parabola is going to be upside down, but I'm going to do everything exactly the same. So I need my other points on the graph. And let's draw in our axis of symmetry. There we go. Because we're going to need that later on. And let's pick some points. All right, so I went to the left last time. Let's go to the right. Why not? Let's use 5 and 7. Let's not do the next one. Let's do 5 and 7. Let's see how those numbers work out. All right. So all I'm going to do is, like, once again, plug these in. It's negative 1/2. I'm going to plug in a 5 minus 4 squared plus 2. All right. Let's calculate out the f of x or the y. Negative 1/2. 5 minus 4 is 1. Plus 2. Oops. Plus 2. Oh, wait, there we go. 1 squared is simply 1. Plus 2. Negative 1/2 times 1. It's going to be a negative negative 0.5. Right? Negative 1/2. We're negative 0.5. Plus 2. All right, negative 0.5 plus 2 is going to give me a positive 1.5. All right. Now we can plot that point. Over 5, positive 1.5. Over 5, 1.5 is going to be right there. Now it's kind of like in the middle. All right, let's do the other one. Let's do 7. Notice it's down below the vertex because it's going to go down. All right, let's do 7. Negative 1/2. Plug in my 7 minus 4 squared plus 2. All right, all I'm doing is plugging in a positive 7. Everything else stays the same. Negative 1/2. If I do what's inside the parentheses, I get 3. I still have my squared plus 2. All right, so if I square 3, 3 times 3 is 9. I get negative 1/2 times 9 plus 2. Half of 9 equals negative 4.5. Because remember, we're multiplying a negative times a positive, so we get a negative. All right, this is going to be plus 2. I'll do negative 4.5 plus 2. That gives me a negative 2.5. Now I have my second point, negative 2.5. All right, so I go to 7, go down 2.5. That's right about there. And now I have my second part. Here's my second point, so I can start graphing my graph. And once again, don't forget, we got to graph the other side. So my first point is going to be here because it's 1 point away. Now this is 1, 2, 3 points away from my axis of symmetry. So I'm going to go 1, 2, 3 points away. And there we go. We have our parabola. It's upside down because it's negative. It's a little bit wider, right? Because we have a fraction out in front. And that's about it. All right, if you have any questions, please see me in class. Or if you're not in my class, please leave a comment down below, and I'll be sure to comment back. Take care. Have a good day.